Welcome to today's lecture. We're going to talk about statistics. Well, what is statistics? Statistics is a branch of math dealing with data. Statistics is a branch of math. It consists of some steps. The very first step is collecting data. Data, numbers, values coming from observations, counting, surveys, and so on. So the very first step is collecting the data. After we collect the data, in step 2, we're interested in visualizing the data. What's the graph or shape like? Visualizing the data. Okay, after we visualize the data, we have a normal distribution. Is it skewed to the left? It's skewed to the right, and so on. We're interested in actually analyzing the data. What is the mean? What is the standard deviation? Where is the center? So we jump into step 3, analyzing the data. Well, after we analyze the data, suppose you collected information about the other students' SAT grade, SAT score. You're interested in comparing those scores to other schools. So you're trying to make inferences. Step 4, make conclusions to the population. Making inferences or conclusions. So if someone asks you, what is statistics? You say that, hey, statistics is a branch of math. It includes some steps. The first step is to collect data. We have a question and we're interested in answering that question, so we collect data. 2, after collecting the data, we're interested in visualizing the data. What's the graph like? After that, we're interested in analyzing the data. What's the numerical characteristics that we can actually assign to the data? And finally, making conclusions, inferences about other data or the population that was very hard for us to collect the data. This is the definition of statistics. So what is data? We keep saying that, hey, collecting data. Data or data is collection of values. It might be not just numbers. It might be hair color or blood type. So collection of values or counts or observations. Okay. I expect you to ask this question now. Sometimes you have some collections that are easy to count. For example, students sitting in this class. We have 46 students sitting in this class. I can easily ask each one of them, what's your favorite color? Ask each one of them, what was your GPA? What if I want to collect data from all students in the United States? So, I have all students in the US, and I have students sitting in this class. As you can imagine, it's a very small portion. Let's use a different color for that. Answer 10 students. So this is just an example. Do we actually have a name for that? All students in the US are actually part of a category that we call population. So this bigger set, this larger set is called population. Population of students in the United States. This small portion, sub-collection, subset of the population is called a sample. Officially, we define it this way. A population is the collection of all, every outcomes, responses, measurements, or counts in the collection. So, definition. Population includes, guys, here we have a small keyword which is super important. All, every, related to population. So population includes all or every. If you see all, every in an example, in a question, it means that it's referring back to population, that big or large set. All, every. Every count, measurements, observation. Measurements, counts, observations, and so on. Again, keywords, all, every. Sometimes they are hidden, sometimes you can just spot them in the question. This is the definition of population. All students in the United States. You ask every student in the United States, what is your GPA? You collect the data from every one of them. It's a huge population, very big. You need to have enough resources, you need to have enough money to be able to collect data from each one of them. It takes forever. Population. Instead, they just select a random college like the Pienza. They select a random class, Math 10. They ask students in Math 10 class, what is your GPA? A sample. Definition of a sample. Sample is a sub-collection or subset of the population. Our very first example, identifying data sets. Well, in a recent survey, 614 small business owners in the United States were asked whether they thought their company's Facebook presence was valuable or not. 258 of 614 respondents said yes. In your view, what is the population and what is the sample? So,
business owners.
Very good. The population includes all small business owners in the United States. Remember the definition of population. It includes all. So here we have this information. We have all small business owners in the US. Okay, this is the population. Out of this population, 614 were surveyed. 614. Small portion. 614%. So out of these 614, some responded yes, some responded no, some they didn't even respond. It includes some portion. You're the statistician. You collected the data, and then these data in the sample includes some portions. Some said yes, some said no, some said we don't know. So the population is actually all small business owners in the United States. Out of that population, you collected a random sample of 614. Point. The US Department of Energy conducts weekly surveys. Another keyword for you when we are talking about surveys, measurements, counts related to a survey, it means that we are dealing with samples. Weekly surveys of 800 gasoline stations determine the average price per gallon of regular gasoline. On December 10th, 2012, the average price was $3.35 per gallon. Identify the population and the sample. The population is all gasoline stations gasoline stations is your population. Now here, 800 of them were surveyed. A small portion, just 800. So again, keyword survey. When you see survey in a question, in an example, it means that it's related to a sample. Another keyword for you, survey. So this sample includes 800 gasoline stations. So in general, when you're talking about population and you're saying that, hey, for example, the mean of the population, the average of the population, the standard deviation of population, instead of keep saying the mean of population, the standard deviation of population, we refer to those as parameters. So we have a population and we have a sample. Let us use sample with red and population with black. So numerical characteristics for a population, they are called parameters of a population. Numerical characteristics. What are numerical characteristics? Like the average, like the standard deviation. Average, mean, standard deviation, and so on of population are called parameters. When we are talking about numerical characteristics of a sample, you're actually working with statistics. So, numerical characteristics. Again, like the average of a sample. What is the average GPA of Math 10 students in De Anza? We are referring to those numerical characteristics related to the sample as statistics. Average, standard deviation, range, and so on. We're going to talk about this later of sample are called statistics. Determine whether the numerical value described a population parameter or a sample statistic. Explain your reasoning. Let Let's answer question 1. A recent survey of approximately 400,000 employers reported that the average starting salary for marketing majors is $53,400. Question says a recent survey. Very well. Excellent. Excellent, Kimberly. Mean excellent. Survey is related to sample. When we have sample, we have sample statistic. Numerical characteristics like average, standard deviation, and so on of sample are called statistics for those samples. When we talk about sample, the keyword that's saying, hey, you actually have a sample was one of the famous one is survey. In this example, we have keyword survey. When you have survey, it means that you have a sample. When you have a sample, you have sample statistic. The average of your sample. So these are all come together as a chain. Remember that. You have a survey related to sample. Sample, okay. Characteristic, numerical characteristic of a sample, statistic. So, 2. The freshman class at a university has an average SAT math score of 514. Is this average a numerical characteristic for population? Is it a parameter, or is it a numerical characteristic for a sample? Is it a statistic? Which one is that? So let's read the question one more time. The freshman class at the university has an average SAT math score of 514. We don't see any keyword related to a sample. We don't have anything like a survey or out of, a sub-collection, a proportion. It says, hey, you have a class, and in that class, the average is 514. You have the entire class. So it's entire class. Every one of them was counted. Everyone, each one, equivalent to, equal to all, equal to every student. They're asked about the SAT score, and the average is actually calculated. So that entire class represents the population. Every was calculated, was counted, so the entire class represents the population. So it means that the numerical characteristic of the average SAT is nothing but the parameter. So next one. Okay, here we go. In a random check of 400 retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. This 34% is the numerical characteristic. Is this related to population or is this related to a sample? In a random check of 400 retail stores, we didn't have time to go to every one of them. We didn't have enough money. We didn't have enough resources. We didn't have enough time. Just randomly selected some. So what's the meaning of that? This randomness is related to a sample. So another keyword for you, random. And we're dealing with surveys, dealing with randomness. It means that we have a sample to work with. We have a sample, numerical characteristic for that sample is your statistic. Very well. Last year, a company with 65 employees spent a total of $5,156,094 on employees' salaries. Does the amount spent describe a population numerical characteristic or population parameter, or is it a sample statistic? Sample numerical characteristic. Which one is that? So note that even though you only have 65 numbers, everyone is counted. 65 numbers, but every salary is counted. So it's going to be population. Entire company. Every one of them is counted. So it's going to be population parameter. Very well. So remember how to define statistics. We said, hey, statistics is a branch of math. Well, of course it's a branch of math. It deals with numbers, formulas. But it includes some steps. Statistic is a branch of math. In step one, after asking the question, you always start by asking a question. What is the average SAT score of the Yale College students? We collect the data. Collect data. Step two, visualize the data. Then we move on to the next step. We analyze the data. And finally, make conclusions about populations or other data. So, make conclusions. Well, so data. How do we classify data? How many types of data do we have? In this class, we're going to deal with two types of data. So our data in this class has two categories. The first category is called numerical numbers, meaningful numbers. Let's say meaningful numbers. Numerical or quantitative. Quantitative data. numbers like height, like weight, like SAT scores, and so on. Height, weight, scores, and so on. The second one is called categorical or qualitative. It comes from quality. So categorical or qualitative. Like what? Like hair color, blood type. Hair color, blood type. Well, there are some numerical data that are not part of quantitative categories. Like what? Well, consider social security numbers. Social security numbers, postal codes. Even though you see digits here, you see numbers here, they are not numerical data. Why is that? So, note that we say a collection of data is numerical if you can do algebra, and the algebra gives you meaningful information. So note that. A collection of data is numerical or quantitative. Quantitative if we can do algebra and it gives us meaningful information. Meaningful information. What's the meaning of that? Algebra, meaningful information. Well, suppose you collected social security numbers. Suppose you find the average of social security numbers. Is it meaningful to say that the average of social security numbers is that number? Or suppose you collected postal codes of a region, of an area, and you find the average. What's the meaning of average of postal codes? It's not meaningful at all. So it means that even though you can do algebra, the result is not meaningful. So social security numbers and postal codes are not numerical. They are categorical or qualitative. So let us take a look at one example. Very well. Classify data by type. What do we have here? The suggested retail prices of several Honda vehicles are shown in the table. Which data are qualitative data? Which ones are categorical data? And which ones are quantitative data? What do you have? You have the model and you have the price.